So good. So now that we are all set to start, all right, from where we were in the last class and whatever we were doing. So let us start from there. Okay. We were, if we recall what we were doing in the last class, we were trying to understand the interior of the Earth. Okay. And in that we did the direct sources and the indirect sources. And while talking of the indirect sources, we talked of the S waves and their role. So what is the role that the S waves play in understanding the interior? And we finalized or we understood that in understanding the roles of the seismic waves, we understood that S waves tell us that in the interior of the Earth there is a liquid core region in the interior at a depth of 2900 kilometers from the surface of the Earth. We have a liquid core region. So this is what we concluded in the last class from our S wave studies. Why? Because the S waves tend to bend for any given earthquake. Suppose the earthquake is taking place here. So for any, they tend to reach, suppose this is the 0 degree with respect to that earthquake. Suppose this is the focus and the epicenter. So this will be 180 degree on the other side. So up to 105 degrees, the S waves are able to appear on the surface of the Earth. 0 to 105 degrees, they are able to appear on the surface of the Earth, mainly because in this, for reaching this 0 to 105 degrees, they don't have to go into the core. They don't have to cross the core. Therefore, from 0 to 5 degrees, 105 degrees, they are able to appear. Whereas, for reaching the area 105 to 180, they have to cross through the core. And S waves cannot cross through the core. Therefore, they are not able to pass through. Okay. So, if you want, you can note this down in your copy also, that in the S wave studies, yeah, good morning everyone, very good. Okay, so in the S wave studies, we saw that, or we learned that there is a liquid core region at a depth of 2900 kilometers from the surface of the Earth. We learned that there is a liquid core region at a depth of 2900 kilometers, and the S waves are not able to pass through this liquid core region. S waves are not able to pass through this liquid core region. Not able to pass through this liquid core region. Hence, with epicenter as 0 degree, the S waves appear up to 105 degrees, all over the surface of the Earth, because for 0 to 105 degrees region, for reaching the 0 to 105 degrees region, S waves don't have to pass through the liquid core. Don't have to pass through the liquid core. And these travel only in the solid mantle. These travel only in the solid mantle. Travel only in the solid mantle. Gustav? S waves are not able to reach from 105 to 180. S waves are not able to reach from 105 to 180. Because for reaching this region, for reaching this 105 to 180 degree region on the surface, for reaching this 105 to 180 degree region on the surface, S waves will have to cross through the core. Will have to cross through the core, which is not possible. Which is not possible as understood earlier. Which is not possible as understood earlier. Hence, this region becomes the S wave shadow zone. Hence, this region becomes the S wave shadow zone. Okay, so this 105 to 180 is the S wave shadow zone. Now earlier I was taking most of the earthquakes here, so this time I have just shifted the location so that you understand that the angle is with respect to the 0 degree. Okay, clear? Good enough. Now the P wave, role of P wave in understanding the interior. Role of P wave in the meantime, all of you please answer. Is this much broadly clear to all of you? Please do answer that so that I can understand things are moving properly and we can move forward. So is this much clear to all of you? If you have any doubts, we have discussed earlier, you should be sending it to the coordinators. The coordinators would be sending it to me. Okay, so is there any so is this much broadly clear? Yes or no? If you have doubts, please send it to the coordinators. They will forward it to me. Please do answer. Is this much clear? I expect an answer from all of you so that we can proceed forward fast. Role of P waves and understanding the Earth's interior. Okay, what role do P waves play? Okay, so to understand the role of P waves, yes sir, I do see a lot of yes sir. Okay, which is a good thing. Everyone has said yes sir. No major doubts have come to me. coordinators. I don't see any major doubts coming. That means this much is clear. Okay, very good. So now let us move to this P wave role. Now, in understanding the role of the P wave, one thing that I would do here is maybe I'll start drawing on the board here directly, okay, on the tablet. That will help me in ensuring that even if there is some voltage fluctuation because of which the screen goes off, because once the screen goes off, everything drawn on the screen also goes off. Okay, so I'm drawing on the tablet so that whatever I display, even if the screen switches off, the content is not deleted. Okay, so I'll draw on this, and I don't think there should be any major challenge. Okay. Good. So, in understanding the role of P waves, what was the expected behavior? We expected that for the P wave also, for any epicenter, the wave should reach everywhere. Okay, from 0 degree to 100 degrees, 105 degrees. But first we draw the observed. What is the observed? Expected was, we already know. Now we do the observed P wave measurement. Okay, observed, right? Practically observed P wave measurement. What do we observe is that if suppose this is the focus, okay, focus, and this is the epicenter. Please do draw with me. Observed P wave measurement. This is the focus, this is the epicenter, and considering the epicenter to be 0 degrees, if we consider epicenter as 0 degrees, obviously the other end of the earth becomes 180 degree, somewhere here, the bottom you can see here, this region. Okay. सर बोर्ड पे लिखें प्लीज, आप जब बोलते हैं तो मैं नहीं लिख पाता हूं जल्दी से। लिखना सीखिए, आप ग्रेजुएट हैं, ठीक है, ऐसा नहीं चलेगा, राइट, कि सर आप बोलते हो तो मैं लिख नहीं पाता हूँ। When I will dictate, I'm not dictating anything right now, I'm just drawing. I expect you to just draw this much, okay? When I will dictate, I'll tell you, but draw तो कर सकते हैं ना विशाल। ऐसा करेंगे तो फिर देखो, प्रॉब्लम ये है कि the place that I'm taking the class at, there are at times some voltage fluctuation which put the board off. मैं पहले भी बोल चुका हूँ, उसका वजह से सारा ड्राइंग डिलीट हो जाएगा, ठीक है। सो आई ड्रॉ इट ऑन द टैबलेट, टैबलेट से डिलीट नहीं होता है, ठीक है। तो इतना तो आप समझ सकते हैं, और उसी के लिए कर रहे हैं, राइट। अगर बिल्कुल भी हम कोऑपरेट नहीं करेंगे तो क्लास करना मुश्किल होगा। इफ वी डोंट कोऑपरेट, क्लासेस विल बिकम डिफिकल्ट, देन आई विल गो ऑन रीड्राइंग एंड, ठीक है। So this is the epicenter, this is 180 degrees, and this is a waste of time. These kind of requests are a waste of time, I should say. So maybe in future I won't pick them up. ऐसा बच्चों के जैसा बिहेवियर करोगे तो 0 to 180 degrees, okay, You should be more concerned about the content rather than कि सर कहाँ ड्रॉ कर रहे हैं, कैसे ड्रॉ कर रहे हैं. ठीक है. So please focus here. 0 to 180 degrees, right? This is the earth thing. Now what we observe is that the P wave appear at up to 105 degrees on the surface of the earth. The P waves also appear. P waves appear here. ठीक है. Up to 105 degrees, just like S waves, they appear up to 105 degrees. Okay. And from 105 degrees to 145 degrees, not 180, 105 degrees to 145 degrees, they do not appear on the surface. So which region they don't appear? P waves do not appear on surface. P waves do not appear on the surface here. 105 to 145 degrees. If you are not a graduate, then you should. मतलब विशाल ऐसा आंसर करोगे तो कैसे काम चलेगा यार. बच्चे थोड़ी हो, ग्रेजुएट नहीं. अच्छा बोल दो सर 12th भी नहीं पास किया, 10th भी नहीं पास किया, ऐसा थोड़ी है. Okay, so P waves do not appear on surface, something like this. ठीक है. You must learn the things that we are teaching you here. You must learn this. I don't know what kind of college backgrounds you people come from, right? And that doesn't matter in UPSC. That's why you are preparing. ठीक है. But I don't know how your teachers are teaching you in the college, but for UPSC civil services, until unless you behave maturely, you will never clear the exam. Right? So you should learn in these classes how to behave like a UPSC aspirant. Okay? So you should be in a position to write, if you have taken English as a medium, you should be in a position to write and read the things that we are doing. Lakhs of students are doing this, they are competing, so you should also. Otherwise, there is no possibility of you being present in the top 1000 at any cost. Right? So please behave like that way, right? Like mature people, right? Learn through these classes. That's what these classes are supposed to do for you. ठीक है, समझिए. ऐसा आंसर करने से नहीं चलेगा सर, नहीं मैं ग्रेजुएट नहीं हूं, ये भी बोल दो सर कभी नहीं, मतलब. ठीक है. P waves do not appear on the surface. Clear? So this region we call as the P wave shadow zone. P wave shadow zone. And what is the angle of the P wave shadow zone? 105 degrees to 145 degrees only, unlike S wave, which has 105 to 180 degrees. So P wave shadow zone is from this to this. None of them are dangerous because they do not do anything to us. The P waves appear on the P waves and the S waves reach the surface. There they generate the surface wave. The surface waves are the ones which shake the earth, which we feel, and they cause the earthquake. So earthquake is not directly created by P wave, S wave. The earthquake is created by surface wave generated by P wave and S wave. Okay, so we can't say about these only. Right? So hopefully we get it. P wave, shadow zone 105 to 145 degrees, right? And then in this region 145 to 180 degrees, P wave again appear. This region 145 to 180 degrees. I'm writing this on the side. You can see this. P waves again appear on the P waves again appear on the surface. Okay, so this region 145 to 180 degrees, the P wave again appears on the surface. So the shadow zone confines only up to this 105 to 145. Is this clear? Okay, right? Perfect. Now, what does this imply? We know, please see, what does this imply? We know that from the S wave study itself, we know that there is a liquid core, and we also know that the P waves are able to reach up to 105 degrees, somewhat like this. And in the center, we have a liquid core region, something like this. Okay. This liquid core region we know from the S wave studies. Okay. So this is the liquid core. Now we know that the P waves are able to pass through the liquid core. So let me draw some more. No, they are not visible. So let me use a different P waves. Okay. So something like this. But you see that these P waves that I'm drawing, they are entering the liquid core and they are bending. And because they are bending, this one, right, it is able to appear only at 145 degrees. Right. So the P waves which are entering the liquid core are able to, first they bend, and because they bend, they are able to appear only at 145 degrees. So the one which are not entering, are not bending, they are appearing up to 105, whereas the ones which are entering and bending, ones which are entering and bending, they are able to appear only from 145 to 180 degrees. Okay. So this way we see that the P waves are bending in this region in the liquid core, and they are bending twice while they are entering. Actually, they are bending more, but we'll understand that later. So they are bending like this. Okay. And this is why they are bending and they are able to appear only at 100. So two waves starting, one of them enters, one of them does not enter. So it appears without bending in the core at 105. The other one enters the liquid core and hence it bends twice and appears only at 145. Hence in this in between region, there is no P wave, right? The one not bending 105, the one bending 145. So there is a 40-degree bend in the core. You can say this way. Okay. And because of this 40-degree bend, it is able to appear only at 145. Okay. Please send your doubts to the classroom coordinator, whatever you have. Okay. Right. So this is how those P waves are bending. Okay. Clear? Okay. Now I would expect you to write your doubts to the coordinator. I won't be taking up because then we will slow down the class. Okay. And they will send it to me wherever needed. Right. And when I will ask you doubts, then you can send them directly to me. But if I don't, then please send them to the coordinators, all of you. Okay. So first of all, you can see all these are bending, not some, all of them which are entering into, they bend. Okay. So all the ones which are entering into the core, which are able to reach up to the core, they are bending. The ones which are not able to reach up to the core, they are not bending that way. They are bending slightly and they are appearing up to 105. Okay. The ones which are entering into the peak, the core, they are, as you can see here, bending this way. Clear? Okay. So now write down. Once you have drawn this, please write down. Right? Write down. As we can see in the diagram, as we can see in the P wave diagram, that the P waves which don't reach up to the core, the P waves which don't reach up to the core before reaching the Earth's surface, P waves which don't reach up to the core before reaching the Earth's surface appear in the region of 0 to 105 degrees with respect to epicenter. Reach the surface between 0 to 105 degrees with respect to the epicenter. Whereas the P waves which reach the core before appearing on the surface of the Earth, the P waves which reach the core before appearing on the surface of the Earth bend while entering and exiting the core. Bend while entering and exiting the core. And hence are able to appear on the surface only, between 145 to 180 degree. And hence are able to appear on the surface only between 145 to 180 degrees with respect to the epicenter. With respect to the epicenter. Full stop. This way we see that all the P waves entering the core bend. Full stop. Next paragraph. The bending in the core will be proportional bending in the core will be proportional to the difference in density between the core and the mantle. How much is the difference? That much they will bend. Okay, whatever is the difference, that much they will bend. Is proportional to the difference in the density between the mantle and the core. Hence, the P wave studies help us to calculate the density of the core region. S wave studies tell us that core is liquid. P wave studies help us to calculate the density of the core region. Calculate the density of the core region. Stop. Underline. P-wave studies help us to calculate density of the core region. Hence, understanding the state and the density of the core. Hence, by understanding the state and the density of the core, we can figure out which compounds and minerals we find in the core. Figure out which compound and mineral we can find in the core. This way, we understand the state. Density, and the material of the core. Is this clear? Right. So this is how our P-wave studies help. Now write down next paragraph. There are more studies based on the seismic waves. Which are done to understand the Earth's interior. But these are beyond the scope of our syllabus. These are beyond the scope of our GS syllabus. Such as the speed-based studies, etc. The PNS waves, speed-based studies, etc. Beyond the scope of our GS syllabus, such as PNS wave, speed-based studies. The final picture of the Earth interior, as we understand, is as given below. Final picture of the Earth interior, as we understand, is as given below. Okay. So let us try to understand this final picture of the Earth's interior also. So let me draw this on the board and you people can simultaneously draw. Earth's interior. Okay, Earth's interior. That's the subheading that we put. And please draw with me, all of you. Please be careful in drawing this part that I'm drawing. Okay, draw as many layers as I'm trying to show in this. Okay. Now, what all are we trying to show here? I will also slightly shade a part so that you are clear in your drawing. Hopefully you can see, and I'm writing in that ocean. This is the ocean part. So obviously below the ocean you have the ocean surface or ocean floor. Okay. Now please see this part of the diagram again. All right. Right. So please draw accordingly as I'm drawing. Right. These are the different regions that we are trying to show. Is this clear? So how many center then? And I'll write the distance also. Okay, so I'm writing the distance at some places. This is at a depth of 6,400 kilometers approximately. Depth is 6,400 kilometers. Okay, approximately 6,370 your NCERT gives. 6,378 some other sources give. So we round it off to 6,400. Right, that is the depth. Then this one is at 5,100 kilometer depth. Okay, and this one is at 2,900 kilometer depth. All right. And this one is at a depth of around 700 kilometers. Something like this. Okay, good enough. So this is the diagram that I want you to draw. Once you have drawn this, now I'll make you understand this diagram. Right. So basically what you find is that this is the oceans and this side you have the continent. This whole thing is the continent. Let me write थोड़ा सा और नीचे. continent. Alright, and on the continent, what are the different parts that we have drawn? The different parts on the continent are, this is the plane. On the continent, this is the plane. Please do draw with me. This is the plane. This is the plateau, higher than the plane. And this is the mountain. I'm just writing empty dot. Empty dot is mountain. That is mountain. Okay. Plain, plateau, mountain. Three parts of the continent we have shown. Is this clear? Right? Hopefully. Not very complicated. Okay. Very good. Now let us try to understand the different parts. Now, before I take you to the different part, there is another small thing that I would like to write here on the side, which is, please see, if I write H2O, right? Now, H2O is a chemical compound. It's a chemical mixture or a compound, H2O, right? Which means it is the chemical characteristic is H2O. You can say it is H2O is the chemical characteristic, and the physical characteristic of the same could be written as ice, water, steam, water vapor. All this is the physical characteristic. Okay. Whereas writing H2O is the chemical characteristic. Right. So H2O, when we say H2O, we are talking of the chemical characteristic, what it is made up of. When we say water, steam, ice, okay, water vapor, we are talking in terms of its physical state. So you can say this is the physical state. Okay, physical state. So basically, you can talk of the chemical characteristic of something, or you can talk of the physical characteristic of something. Right? Chemical characteristic means what it is made up of. Physical characteristic means what physical state it has, whether it is in a liquid state, or it is in a solid state, or it is in a gaseous state. यही है ना? Ice, solid, water, liquid, and steam and water vapor, gas. But these are the solid, liquid, and gas of H2O. Hopefully we understand this. Same ways, when you look in the interior of the earth also, one, there will be chemical characteristics. What is the interior of the earth made up of? So what is it made up of? Right? Chemical compounds of the interior. That is the chemical characteristic of the earth. And what state it is in. What state? Whether it is in a physical, whether it is in a solid state or a liquid state. Right? What state? That is the physical characteristic of the earth interior. Okay. So this way we can talk of the earth's interior also in two ways. The physical characteristic and the chemical characteristic. Do we get it? So please note this down. Write this. I'll dictate and write down. Right? When we talk of the interior of the earth, we'll generally find that the interior will have two characteristics, physical characteristic and chemical characteristic. The interior will have two characteristics, the physical characteristic and the chemical characteristic. Where the physical characteristic will tell the state of the interior. Physical characteristic will tell the state of the interior. Whether it is solid, state of the interior. Physical characteristic will tell the state of the interior, whether it is solid and then rock solid or weak soft solid, whether it is rock solid or weak solid like plastic, whether it is rock solid or weak solid like plastic which can bend, whether it is solid, and then whether rock solid or weak solid like plastic which can bend, or liquid, liquid. So it should be noted that liquid can also be denser than solids. It should be noted that liquid can also be denser than solid. Like water is denser than wood. Like water is denser than wood. Hence, wood floats on water. Same ways, mercury is dense. Mercury is liquid and denser than many solids. Same ways, mercury is liquid and denser than many solids. Okay, this is just to tell that liquids can be denser than solid, because many of you don't, you get shocked when I say this. I've seen this in many batches. Then, next, write down. The second characteristic, the chemical characteristic of the interior, rather than second, you can write the chemical characteristic of the interior tells us whether, chemical characteristic of the interior tells us whether what are the compounds or chemicals or minerals, what are the compounds, chemicals or minerals of which the Earth's interior is made, of which the Earth's interior is made. Earth's interior is made. Okay. So, hence, first we'll discuss the chemical characteristics of the Earth interior. Hence, first we'll discuss the chemical characteristics of the Earth's interior. Okay, so first we talk of the chemical characteristics of the Earth's interior. So when we talk of the chemical characteristic of the Earth interior, we find that the first region is the crust. Crust is the first region of the Earth interior. We find that the first region is the crust. Okay, this upper region, the crust, is the first region of the Earth's interior. Okay, please see here carefully. I have shown that upper region, black to red. Crust is the first region. And this is the oceanic crust. I'll write OC in red color so as to make you understand. Oceanic crust, that you find here, OC. And you find oceanic crust also below the continents. Oceanic crust. Oceanic crust. Okay, all this is the oceanic crust. this black to red region is the oceanic crust. Okay, so the first one is the oceanic crust. Okay, oceanic crust, OCOC, written in black, red color. That is the oceanic crust. Okay, and the continent is made up of, I'm writing in a blue color there, continental crust. The whole continent is made up of continental crust. And the continental crust is lying over the oceanic crust. Also. Okay, the continental crust. So there are two types of crust, continental crust and the oceanic crust. Right, continental crust and oceanic crust. Two types of crusts are there. All right, clear? Continental crust and oceanic crust. So, please, you can write here. The crust again has two parts. Continental crust and oceanic crust. Okay. Continental crust is the lighter crust, oceanic crust is the slightly denser crust. All right. Now, what do we have below the crust? The region below the crust. Okay. Let me use a bluish color for up to a depth of 2900 kilometers. This is called as the mantle region. The region just below the crust up to a depth of 2900 kilometers. Now, one more thing that I want you to tell you here is, what is the depth of the oceanic crust? Depth of oceanic crust, वो भी लिख लेते हैं. Oceanic crust is 5 kilometer deep. The oceanic crust, वो लिख लेते हैं पहले, 5 kilometer deep. Oceanic crust is 5 kilometer deep. Okay. Whereas the continental crust depth varies. Right? The continental crust depth varies from 30 kilometers to 70 kilometers. 30 kilometer to 70 kilometer. Where is it 30 kilometers? In the plains. The depth of the oceanic continental crust is 30 kilometers. In the plain, the depth of the continental crust is 30 kilometers. In the mountains, the depth of the continental crust is 70 kilometers. Mountains, the depth is 70 kilometers for the continental crust. Is this okay? So, this 30 kilometer, there 70, and plateau will be in between. Not as less as 30, not as high as 70. Different plateaus, different height. Okay, so 30 to 70 kilometer is the thickness of the crust, continental crust, and oceanic crust is 5 kilometer thick. Is this understood? One more thing I want you to write down here is that the rocks of the crust, the continental crust has a density, rock density. वो भी लिख लीजिए आप. rock density of the continental crust is 2.7 grams per centimeter cube. The rock density of the continental crust is 2.7 grams per centimeter cube. Rock density of the oceanic crust is 3 grams per centimeter cube. Rock density of the oceanic crust is 3 grams per centimeter cube. Okay, 3 grams per centimeter cube. Clear? Now, we come to the mantle. The mantle extends from where? So, just below the crust, you have the mantle. Just below the crust, all the region is called as the mantle. Okay. And the mantle lower part is 2900 kilometer. From what? From where will the mantle start? Depends. Below the ocean, it will start from 5 kilometer. Below the mountains, it will start from below 70 kilometers because the crust itself is 70 kilometer at the mountain. So the mantle will start at different places, but the lowest point will be 2900 kilometer from the surface of the earth. Okay, so that is the mantle region. Okay, and then lastly, you have the core region. Which is from 2900 kilometer to 6400 kilometer. We call it as the core region. Now, what is the chemical composition of the core, mantle and crust? Chemical composition. Let us see. Right, because we have done this as a chemical characteristic. So, what we should focus on the chemical composition of this. The core, as per your NCERT and GC Leong, is made up of nickel and iron and nickel, or nickel or iron. NiFe, nickel and iron. We call it as knife or NiFe, whatever you call. The core is made up of nickel and iron. So we call it as NiFe, NiFe. Ni for nickel, Fe for iron. Iron. So core is made up of nickel and iron. Whereas when you talk of the crust as per your NCERT and GC Leong is made up of silica and alumina, not silicon and aluminium, silica and alumina. Si, silica, Al, alumina. Right? So Si is silica. Silica is oxide of silicon. Okay, oxide of silicon. So silica, which is the oxide of silicon, and alumina is the oxide of aluminium. Alumina is the oxide of aluminium. Right? Right? So crust is made up of SiAl. We call it as Sial. Right? But your NCERTs or the GC Leong, when you read, there is again a slight factual distortion which we have to correct. When you read your NCERT says that the continental crust is made up of Sial, and the GC Leong also. Continental crust is made up of Sial and oceanic crust is made up of SiMa, SiMa, silica and magnesia. Magnesia is the oxide of magnesium. So your NCERT says that the oceanic crust is made up of SiMa, continental crust is made up of SiAl. But the problem is neither your NCERT nor your GC Leong tell you what is the mantle made up of. They have skipped it. They are silent. Nothing mentioned, which is wrong. Okay? Basically, your crust is made up of silica and your mantle is made up of SiMa, silica and magnesia. Your mantle is made up of silica and magnesia. Magnesia is the oxide of magnesium. Okay. Now, then what is the difference between crust and oceanic crust and continental crust? So, hopefully you have written. crust made up of SiAl, mantle made up of SiMa, silica and magnesia, and the core made up of NiFe. Now, what is the difference between continental crust and oceanic crust then? The difference between continental crust and oceanic crust is that continental crust is made up of silica plus alumina. Continental crust is made up of silica plus alumina. Oceanic crust, on the other hand, is made up of silica plus alumina plus some magnesia. It also has some magnesia. Oceanic crust has silica plus alumina plus magnesia. So it is Cl plus, oceanic crust is Cl plus magnesia. It has some magnesia in it. So oceanic crust is made up of silica plus alumina plus magnesia. Okay, but keep in mind, if your question is the crust is made up of continental crust is made up of, if the question is like this, please listen. Question is continental crust is made up of Cl, oceanic crust is made up of Sima, core is made up of Nife, then tick it right. Why? Because that is given in your NCERT. Okay, but if you are writing a mains answer, in the mains answer put the right thing that we are learning in the class. So what you are learning in the class, in the mains answer you should write that. If the question is from the NCERT, then you should tick it right. Okay, because GC Leong NCERT both are giving you that oceanic crust is made up of Cl, continental crust is made up of Sima, core is made up of Nife. They are not talking of mantle, they will not ask you that. So if they are asking the question from GC Leong NCERT, you correct it right. But if you are writing a mains answer, there you should write what you have learnt. That crust is made up of Cl, in that continental crust is Cl and oceanic crust is Cl plus magnesia. Mantle is made up of Sima and the other thing. Okay, good enough. Hopefully we understand this. So this is the three regions of the interior. And what is the depth of the core? From 2900 to 400 the core is there. Okay, so these are the three crust, mantle, core. Crust, mantle, core on the basis of chemical composition and their depths, etc. we have understood. Okay, right? Now what do we consider? The core here we are considering as liquid. Part of the core is liquid, whereas all this we are considering as solid. The crust and mantle is both solid. Crust and mantle both are solid, right? But we are not talking, when you are talking of Cl and etc., we are not talking in terms of whether what is the state, we are talking in terms of the chemical composition. Okay, clear? Now come to physical characteristic of the interior. The physical characteristic of the interior, right? Physical characteristic. So we are trying to understand next the physical characteristic of the interior. Okay, now what does the physical characteristic of the interior say? First of all, before I take you into the physical characteristic, is the chemical characteristic broadly understood by all of you? Any major doubts? You asked to the coordinator, but is it broadly understood? Can I say the physical characteristic, the chemical characteristic of the Earth's interior is understood? The crust, mantle and core region, their composition and densities, have we understood? I have not given you the density of the core and the mantle, but at least of the oceanic crust and continental crust. Is that much clear to all of us? Please let me know. Is that clear to all of you? The crust, mantle, core classification, which is chemical composition based. Okay, right? Very good. So the chemical composition based, this region is clear. Now let us come to, very good. Now let us come to the physical characteristic. Right? So, okay, you can write, likh lo usko. Chemical, the chemical characteristic, write down if you feel like, you can write this down. and then we'll come to the physical characteristic. Let me just dictate the chemical characteristic part first. You can write on the basis of chemical characteristic. On the basis of chemical characteristic, the interior can be divided. The interior can be divided. The interior can be divided into crust, mantle, and core. Crust, mantle, and core. Where the crust is divided into continental crust made up of Sial, continental crust made up of Sial, oceanic crust made up of Sial plus magnesia, oceanic crust made up of Sial plus some magnesia, not very high, some magnesia. Oceanic crust made up of Sial plus some magnesia. Mantle made up of silica and alumina. Sorry, mantle made up of silica and magnesia, SiMa. Mantle made up of silica and alumina. Repeatedly I am saying alumina, I'm sorry. Silica and magnesia. Mantle made up of silica and magnesia, SiMa. And core made up of nickel and iron. The core made up of nickel and iron, NiFe. NiFe. Okay. Depths we have given in the diagram, so you can write from there. Now come back to the physical characteristic. Right. So when you talk about the physical characteristic, I want you to write down first. Now put the subheading physical characteristics. Write down the physical characteristic of the Earth interior. Physical characteristic of the Earth interior is on the basis of the regions being solid or liquid, is on the basis of the regions, the different regions being solid or liquid, different regions being solid or liquid. Dictation mandatory है क्या? Dictation not needed. Mandatory नहीं है, but some of you request, so I have to do. I know I have already given the points, but some of you still need it in a dictated form. So at times I have to do, because this comes as a complaint many times that sir आप dictate नहीं करते हो. So I do. ठीक है. Until unless all of you have a consensus that dictation we don't need, then I can stop and I can go on explaining the way I am. But that never happens. ठीक है. So I have to give those parts also. ठीक है. So just adjust with it. Come back. On the basis of whether they are solid or liquid, different regions are solid or liquid, and also And also the further classification of solid regions, into rock solid, hard rock solid, further classification of solid regions into further rock solid, further rock solid, or soft plastic like solid, which can bend and move under pressure. Plastic like solid, soft plastic like solid which can bend and move under pressure. Like the magma region. Also, is this okay? So this is how we will classify the physical characteristic basis. Okay, so now write down next paragraph you start. Next paragraph. The top solid region of the earth, is the hard rock solid layer. The top solid region of the earth is the hard rock solid layer known as the lithosphere. Known as the lithosphere. Known as the lithosphere, which means the sphere of litho. Litho is rock, Litho, litho, right? Which means the sphere of rock. Top solid, the hard rock solid lithosphere. Litho means rock, sphere is the sphere of rock. The lithosphere has a depth or thickness. Lithosphere has a thickness as oceanic lithosphere, has a thickness as oceanic lithosphere, of 10 kilometers. Please do go on writing. As oceanic lithosphere of 10 kilometers. Oceanic lithosphere of 10 kilometers. And the continental lithosphere of 100 kilometers. Continental lithosphere of 100 kilometers, where it is the lithosphere in the plains, where it is the lithosphere below plains. And 200 kilometers below mountains. 100 kilometer below plains and 200 kilometer below mountains. Just write this down. I'll just fix a small power problem and come back in a moment. Okay. So now the power problem, I think we have settled. Okay. Right. So I believe I'm audible and visible. Things are all fine. All right. So you can see amongst yourself itself, the response for dictation and no dictation is 50%. So let us not take this up. Okay. Let's stop that discussion. Please stop. Right. I don't need any further response on that. Right. Because we will never get a consensus on this. This is almost maybe the 30th or 40th or 50th batch where we are trying this. Right. So it never happens. Don't worry. So rather than trying in vain, let us take the dictation as it comes and we will cover the syllabus. Don't worry, that's not your concern. Okay. So let us come back and stop that. And if you don't feel like writing, don't write. That's perfectly fine. Okay, but stop. I don't want any other comment to come after Abhay Dwivedi's comment. Okay. So that's it. All right. So hold on. Now come back. So what have we understood here? We have understood that you can write lithosphere, oceanic lithosphere, 10 kilometer, continental lithosphere, 100 kilometer below plains, 200 kilometer below mountains. Please write this down. I have already dictated this. Hopefully this is already written in your copies. Okay. Right. So now if you see, what you find is that by this logic, the thickness of the lithosphere goes even below the crust. Okay. The lithosphere goes even below the crust here. So the crust is only up to the red line. Below the crust also there is a part of the lithosphere, which is basically the part of the mantle. Okay, this is the upper rock solid mantle. Okay, so you can write this once you have written this part, the dictation that I have given, this thing, this part. Once you have written this, then you can write hence we see that the lithosphere comprises of the complete crust. Hence we see that the lithosphere comprises of the complete rocky crust region. The lithosphere comprises of the complete rocky crust region as well as the top rocky mantle. The top rocky mantle. The top rocky mantle, which when the top rocky mantle, which when together with the crust, is known as lithosphere. Top rocky mantle, this region below the red, this whole thing, top rocky mantle, which when together with the crust is known as lithosphere. The density of the top rocky mantle part, the density of the top rocky mantle part, the density of this top rocky mantle part, only this part, top rocky hard rocky mantle part. The density of this top hard rocky mantle region is 3.3 grams per centimeter cube. Is 3.3 grams. Oceanic crust 2.7, continental crust 3, hard top rocky mantle region 3.3 grams. Okay, which is part of the lithosphere. So lithosphere is hard rocky there. What is the characteristic of lithosphere? The lithosphere is hard rocky, hard and rocky layer. Okay. Then below the lithosphere, what do we have? Below the lithosphere, up to a depth of 700 kilometers, just below the lithosphere, up to the depth of 700 kilometers, we have the region known as asthenosphere. We have the region known as asthenosphere. This part of the mantle is called as asthenosphere. Asthenosphere. Just below the lithosphere, the region is known as asthenosphere. Okay, asthenosphere. And what is the characteristic of the asthenosphere? It is weak plastic solid. It is not rock solid. It is weak plastic solid. Weak plastic solid. And what does it comprise of? It is the magma region. This whole region is made up of magma. The asthenosphere is made up of magma, which is weak plastic solid. It can bend and move under pressure. We call it as asthenosphere. Asthenosphere, magma region, weak plastic solid. Okay, up to 700 kilometers. Now your NCERTs give the depth up to 400 kilometers also. You can write this also. As per NCERT, this depth is given as 400 kilometer. In the exam, if they give you 400 also, that is also right. Now this is where your UPSC preparation wants you to be smart. You have to see the question is coming from where. आप ऐसा नहीं बोल सकते नहीं सर ने ऐसा बोला. Because in some sources and some places they might give you up to 700. Even that is right. Asthenosphere might be up to 700 because the volcanic eruptions come from as deep as 700. Earthquakes also come from as deep as 700. Right? That they happen in the magma region or the lithosphere. So up to 700 also, that's right. And if the question says up to 400, even that is right. Okay. So depends on where the UPSC is asking from. This is smart preparation. Right? So asthenosphere, as per NCERT 400 and as per some sources up to 700. Okay, the magma region. Then below the magma 700 to 2900, this region is again hard solid, but not, I'm not saying rocky. It's hard solid, and this is known as the mesosphere. This region we call as mesosphere. So this part of the mantle, all of these are part of the mantle. You can see the asthenosphere and the mesosphere. They are part of the mantle. So mesosphere is hard solid, asthenosphere is weak plastic solid, magma region. Okay. So mesosphere, hard solid. Right? That is the hard solid region. We call it as the mesosphere. Then the region from 2900 kilometer to 6400 kilometer we call as barysphere. right? You can write the region below or the core region, the whole of the core region, we also call as barysphere. The whole of the core region is called as barysphere, but in this, we again have two states. The upper one is liquid, the inner one is solid. So not the whole core, not the whole core is solid, not the whole core is solid. This should be noted. The outer core is outer core is liquid, whereas the inner core is solid. Okay, outer core is liquid, inner core is solid. Now, some of you might ask, sir, and then why doesn't the S wave travel through the inner core? For reaching the inner core, it has to cross the outer core, na? Outer core is liquid, so it cannot cross that outer core, so it can't reach the inner core. ठीक है, S wave cannot reach the inner core because the inner core is surrounded by a liquid, so it can't cross that liquid thing. Okay, and the whole of the core is called as barysphere also. So these are the different parts of the interior of the earth. Is this clear? Right? That's it. I have to tell nothing else. This is the whole thing. So this is the physical characteristic based interior of the earth. Is this clear? Are these physical characteristics also clear to all of us? Yes or no? Please respond. These physical characteristics, are they clear to all of us? Now, because I have written whatever I wanted to and dictated earlier itself, so I won't dictate any further here. You can see it on the board. Okay. Is this much clear to everyone? An answer yes or no would help. Once this is clear, then I'll take the last part of this and then we'll go beyond. Right? Liquid core. Everything is very clear on the board. You can see. Outer core is liquid and inner core is solid. The whole core is also called as barysphere. Is this much clear? Yes, sir. Very good. Very good. So this is clear as it seems on the board. All the answers flowing in. So now the other thing that we have to do is, okay, write down. Once this is clear, then write down that all these physical and chemical characters, please write down all these physical and chemical characteristic, all these physical and chemical characteristic based regions all these physical and chemical characteristic based regions are separated from each other all these physical and chemical characteristic based regions are separated from each other by narrow zones are separated from each other by narrow zones शिवम सिंह प्लीज सी यू विल अंडरस्टैंड ठीक है पहला क्लास को रिवाइज कर लेना यू विल गेट द आंसर narrow zones separated from each other by narrow zones known as and send your doubt to the coordinators they will answer don't worry narrow zones which are known as discontinuities narrow zones which are known as discontinuities as shown below. Depth of lithosphere I have dictated, you have written on the board, from there you can copy. What option? They will not give you both the option, Ashutosh, I assure you. If they are giving 400, they are getting the question from NCERT. If they are giving 700, they are getting the question from earthquake studies. Okay, so don't worry, they will not give you both. Earthquake studies are not given in NCERT, the depth, etc. Okay, that way. So don't worry. If they give you both, still you should go by 400. Okay, go with your NCERT there. So, and depth of the lithosphere is from 100 to 200 kilometers. Okay. From 10 to 100 to 200 kilometers, we should say that way. Depth is 10 below crust, oceanic crust, and 200 below mountain crust. Are known as discontinuities as given below. So please draw these discontinuities as I'm drawing. All of you. For drawing the discontinuities, first you need three regions. The crust, mantle, and core. Okay, so this whole thing is the crust. This whole thing is the mantle. Please draw with me. This whole thing is the core. Crust, mantle, core, like this first. Three regions we are showing, crust, mantle, core. Now, when we see what separates the crust from the mantle, so the name of the discontinuities we will also write. Discontinuities. Okay, discontinuities. Which are the different discontinuities? So the one which separates the crust from the mantle is called as Moho or Mohorovičić discontinuity. Moho or Mohorovičić discontinuity. The one which separates crust from the mantle. The zone, the narrow zone which separates the crust from the mantle is called as Mohorovičić discontinuity. Then the narrow zone which separates the mantle from the core is called as Gutenberg discontinuity. Gutenberg discontinuity. Gutenberg discontinuity. Okay, now the crust itself is further divided between the oceanic crust and the continental crust. Right, so you have the crust itself divided into upper and the lower crust. Right, the continental crust is the upper crust and the oceanic crust is the lower crust. So that is divided or separated by a discontinuity called as Conard discontinuity. The upper continental crust separated from the lower oceanic crust by Conard discontinuity. Conard discontinuity. Then the region separating the asthenosphere, the molten, from the lower solid, upper from the lower, plastic from the hard. Right, the upper from the lower, plastic from the hard solid. This one we call it as the Repeated discontinuity. Repeated discontinuity. Upper from the lower is known as the repeated discontinuity. Okay, and in the core also, the upper liquid separated from the lower solid. Upper liquid separated from the lower solid. We call this as Lehman-Bullen discontinuity. Lehman-Bullen discontinuity. Okay, the Lehman-Bullen discontinuity. So these are the different discontinuities which we have. What is the discontinuity? The discontinuity is the narrow zone separating one layer from the other in the interior. Right. So what is being separated by what is written here. Okay. In the mantle, the upper plastic magma region is separated from the lower mesosphere by good repeated discontinuity. The upper liquid core is separated from lower solid core by Lehman-Bullen discontinuity, and so on. You can see in the diagram. Okay. So these are the discontinuities. With this, you can write. Hence, with this, we understand the interior of the earth as per the need of the exam. Okay. So this much was needed. All right. Clear? So this part is over. So interior of the earth is over. Now, once the interior of the earth is over, now we come to the next topic. What is the next topic? Interior of the earth is over. So next topic, Earth's magnetism. Earth's magnetism. Next topic, Earth's magnetism. All right. So before I start with Earth's magnetism, first of all, hopefully this much is clear. I won't ask because you would respond yes. If there was any doubt, you must have sent it to the coordinators. If needed, they would send it to me. Okay. So I'm assuming this much is clear broadly. All right. So this is where we take a break of 15 minutes. It is 10:41. We take a 15-minute break. We meet after 15 minutes at 10:56 around, and then we start from there. Okay. So technical team, mic off कर रहे हैं. अभी 15 मिनट का break ले रहे हैं. Classroom coordinators, I'm taking a break. So we have a break here, and if you have any doubts, you can send to the coordinators. If needed, they will send it to me. Okay. Good. Let us start after the break with Earth's magnetism. Okay. So I guess I'm audible. Right. So now let us start our discussion from Earth's magnetism. Okay. So in understanding Earth's magnetism, we would try to see the different aspects that we have with respect to Earth's magnetic character. Okay, so first we need to understand what is magnetism, and then we'll talk of Earth's magnetism. Okay, because I do find some very basic doubts in the mind of many students with respect to magnetism. ठीक है, हम भूल चुके हैं magnetism क्या होता है. Right. So first, let me clarify what do we mean by this term magnetism, and then we'll proceed with magnetism. Okay. So, okay, magnetism. So first magnetism, then Earth's magnetism. So what is magnetism? Now, magnetism is a character which is there. If you want, the ones who don't know the very basics of magnetism can write. Right? Magnetism is a character where the magnet attracts magnetic material towards itself. Magnet attracts magnetic material towards itself. This is the first character. It attracts magnetic material towards itself. Okay, one. Second, a magnet has a north pole. Every magnet has a north pole and a south pole. A magnet has a north pole and a south pole. Okay, and it creates a magnetic field. Creates a magnetic field around itself. Creates a magnetic field around itself, which is the region of influence of the magnet. Creates a magnetic field around itself, which is the region of influence of the magnet. Okay. Creates a magnetic field around itself, which is the region of influence of the magnet. So up to this region, the magnet has its influence. Right. So this is the magnetic field of the magnet in which it has a influence. So anything coming in this region will be affected by the magnetic field. Next, a magnet's pole attracts opposite pole. Magnet's pole attracts the opposite pole of other magnets. Attracts opposite pole of the other magnets and repels similar pole of the other magnet. Repels similar pole of the other magnet. If you take two magnets, then if this is north, then north pole of this magnet will attract the south pole of the other magnet, and it will repel the north pole of the other magnet. Okay, repels the similar pole of the other magnet. Then next point, magnetic fields have the ability to deflect electrically charged particles. They have the ability to deflect electrically charged particles. So if electrically charged particles are coming towards a magnetic field, okay, suppose like this, some charged particles are coming, then they will be deflected by the magnetic field. They will be deflected by the magnetic field. Okay. Electric fields are, if electrically charged particles are coming, then they will be deflected by the magnetic field. They will not travel straight. Okay, they will not be able to travel straight like this. They will be deflected by magnetic field. This is a characteristic of magnetic field. It deflects electric field or electrically charged particles. Okay, good. Now, for every magnet, it has two poles, north pole and south pole. For every magnet, there are two poles. We call them as, for every magnet, there are two poles. We have seen already. What are the name of these poles? The poles are called as north pole and south pole. The poles are called as north pole and south pole. Magnetic north pole and magnetic south pole, obviously. Right? They are called as the magnetic north pole and magnetic south pole. For any magnet you will take, even if you take in your hand, it will have a north pole, which we call as the magnetic north pole, and the magnetic south pole. Do we get it? These magnetic north pole and magnetic south pole are not same as Earth's north and Earth's south. They are not same as. Please do write. These magnetic north pole and magnetic south pole are not same as Earth's north and south. Magnetic north pole and magnetic south pole are not same as Earth's Arctic north and Antarctic south. Not same as Arctic north and Antarctic south. ऐसा नहीं है, मतलब if I take the magnet and it is pointing this way, I can point the magnet holding in my hand anyways. Okay, still I'll call it as north pole and south pole of the magnet. Clear? So this is about Earth, the normal magnet. Last line. Magnetism occurs naturally. Magnetism occurs naturally in some magnetic material. Magnetism occurs naturally in some magnetic material, and it can occurs naturally in some magnetic material, which means they naturally have a north and south magnetic pole, which means they naturally have a magnetic north and magnetic south pole. They naturally have a magnetic north and magnetic south pole. And also, magnetism can also be created. Magnetism can also be created in some magnetic material. Magnetism can also be created in some magnetic material. Okay, so you can also create magnetism in some magnetic material, okay, which might not already have a magnetic north and magnetic south pole. We can create magnetism in such material. Okay, full stop. The simple principle of creating magnetism is, what is the simple principle of creating magnetism? That we'll write. Simple principle of creating magnetism is, the simple principle of creating magnetism is see here. If I take three directions, right? Three directions, all at 90 degree to each other. Three directions, all at What angle? If I take three directions, all at 90 degree to each other. So there are three directions in this, and assume all at 90 degrees to each other. Okay. Three directions, all at 90 degrees to each other, like the corner of a room. If you take the corners of the room, so there is a standing line and there is one side and the other side. So from that corner, there are three directions at 90 degree to each other. And right, 90 degree to each other. And if we have moving electric charge, which we call as current in one direction. If we have moving electric charge, which is current in one direction, moving electric charge, that means current in one direction. If we can get the moving electric charge or current in one direction, and objects movement, movement, let me write it correctly. Objects movement in the other direction, other 90 degree direction, right? Objects movement in the other 90 degree direction. Then magnetic field is created on the object. Magnetic field is created on the object, or magnetism is created on the object in the third 90 degree direction. Magnetism is created on the object in the third 90 degree direction. Okay. And this is the magnetic object, magnetic material or object. Where is the magnetic material or object in this? This is the magnetic material or object in the center. Right. So if I take magnetic material or object, and in that magnetic material, if I can send moving electric charge or current in one direction, and I can send the move the object in the other 90 degree direction. Okay. Then on that object, magnetism is created in the third direction, third 90 degree direction. Okay, magnetism will be created in the third 90 degree direction. This is the simple law of magnetism creation. Simple principle of creating magnetism. Okay, so electric current, physical movement of the object, magnetism. Do we get? Magnetism is created in this direction. All right. Do we understand this? Very simple. I am not using which law, which principle, which direction, which plane, right? Coordinate geometry, वो सब मैं नहीं बात कर रहा हूँ आपसे. I'm not talking at all in all those terms. I don't want to talk. I just want to talk of three things. If I take a magnetic object which doesn't have magnetism, but it can support magnetism, so that is what a magnetic object is. Magnetic material, an object which can support magnetism. Okay? If I take an object, in one direction, if I send electric current, and at 90 degree to that, I move the object continuously, then that object in the third 90 degree direction to itself will create magnetic or magnetism. Is this okay? So this is how the magnetism is created. Now this is the simplest way I can make you understand magnetism without taking the name of the laws and the principles and the direct all that. ठीक है? एंड फॉरगेट ऑल दिस रूल वूल मुझे नहीं चाहिए यहाँ पे कौन सा रूल है. ठीक है, मुझे मत बताइए प्लीज, मैं इलेक्ट्रिकल इंजीनियर ही हूँ, बट प्लीज तो मुझे रूल मत बताइए, अपने पास भी रूल मत लिखिए. फॉरगेट दोज रूल्स इन योर आंसर ऑल्सो. आई डोंट वांट यू टू राइट द रूल, आई जस्ट वांट यू टू राइट नेचुरल प्रिंसिपल. हु फाउंड, आफ्टर हिम द रूल इज नेम्ड. ठीक है, बट ही डिड नॉट क्रिएट दैट रूल, इट्स अ नेचुरल रूल. ठीक है, इन नेचर दिस इज हैपनिंग एवरीवेयर. सो इज दिस अंडरस्टूड? कुमार एक बार आप और पढ़ लेना इसको ध्यान से, यू विल गेट इट. देयर इज नथिंग टू कॉम्प्लेक्स. ठीक है, आई जस्ट सेड थ्री थिंग्स. इफ आई टेक एन ऑब्जेक्ट विच कैन सपोर्ट मैग्नेटिज्म, right, but it doesn't have magnetic properties right now, but it can support magnetism. And in that material, if I can put electric current in one direction, and at 90 degree to that electric current direction I can move the object, then that object in the another 90-degree direction will create magnetic field, or it will create magnetism. Okay, so this is it. If you still don't get it, then you can write that if, तो इतना रट लो इसके लिए, right? So then what you have to write, I'll dictate. So लिख लो, hence as shown in the diagram, hence as shown in the diagram, hence as shown in the diagram, yeah, the object has to be moving to create magnetism. If you have to create magnetism, there has to be some movement which has to happen, then only magnetism, right? So you have to create that way, magnetic movement has to be there. Okay, right? A relative movement with respect to the current and the object has to be there, relative movement. Okay, I'm not using these terms, relative movement and all. Some of you might say, sir, if I take a coil and if I wrap, so what is happening? In that, there's a relative movement in the direction of the current, because the current is going round, it's not going 90 degree. Okay, so there's always a relative movement change. Okay, so basically, very simply said, you write this down. Hence, if we have magnetic material, hence, very simply said, if we have magnetic material, hence, very simply said, if we have magnetic material not having magnetism at that moment, not having magnetic poles at that moment, if we have magnetic material not having magnetic poles at that moment, and in such material, if we can have moving electric charge or current, and in such material, if we can have moving electric charge or current in one direction, moving electric charge known as current in one direction, if we can have moving electric charge or current in one direction, comma, and relatively move the object in another direction, and relatively move the object in another 90-degree direction, relatively move the object in another 90-degree direction, relatively move the object in another 90-degree direction, then magnetism and hence magnetic poles, and then magnetism and hence magnetic poles will be created on the object, then magnetism and hence magnetic pole will be created on the object in the third 90-degree direction, in the third 90-degree direction as shown in the diagram. In the third 90-degree direction as shown in the diagram. right? This is very simply said. I'm trying to make a 5th or 6th class student understand. So this is the 5th, 6th, 7th class student language, right? Where you don't know the physics and anything. Still you can write this much. ठीक है, क्योंकि चार्ज तो सबको पता होता है, 5th, 6th, 7th में आप चार्ज समझ जाते हो, मूवमेंट भी समझ जाते हो, मैग्नेटिज्म भी समझ जाते हो. So I'm just using these 3 basic terms to make you understand. Okay, right? So this is how magnetism is created. Okay, as shown in this diagram. Right? Now, same ways, magnetism is created in the interior of the earth also. Magnetism is created in the interior of the earth also. Same ways, magnetism is created in the interior of the earth also, known as geomagnetism. Magnetism is created in the interior of the earth also, known as geomagnetism. G-E-O, geomagnetism. Okay, known as geomagnetism. So we'll talk of the geomagnetism in a moment. Let me see, there's a doubt put by one of the coordinators. Lithosphere thickness ranges from 10 to 200 kilometer. Crust is not 0 to 100 kilometer. Where did I say 0 to 100 kilometer crust? Okay, so it is 5 kilometer below the oceans, 30 kilometer below the continents, continental plain, and 70 kilometer below the mountain crust. Okay, so 5, 30, 70. Remember these 3 numbers. 5 below ocean, 30 below continental plain, 70 below continental mountain. That is the crust. Lithosphere is 10, 100, 200. Okay, 10, 100, 200. 10 below the ocean, 100 below the continental, 200 below the mountain. That is the lithosphere. Lithosphere equal to crust plus upper solid mantle. Then why lithosphere thickness is not ranging from 0 to 200? Did I say, I'm again correcting, did I say 0? आप पहले डायग्राम में देखिए. This is the benefit of doing these classes. क्या लिखा है यहाँ पे बोर्ड पे, देख लो. कि 0 कहाँ से आया इसमें और 100 कहाँ से आया क्रस्ट में. ओशियानिक क्रस्ट 5, कॉन्टिनेंटल क्रस्ट 30, 70. तो गड़बड़ मत बोलिए. ठीक है. 1 लिथोस्फेयर, ओशियानिक लिथोस्फेयर 10, कॉन्टिनेंटल लिथोस्फेयर प्लेन 100, 200. डायग्राम भी नहीं बनाया आप लोगों ने ठीक से. हाउ आर यू गेटिंग दीज डाउट्स? वर्षा, मीना and others, whoever has sent the doubt this way. Okay, Kapil sir, in case the language or the numbers in the doubts are different, you can hopefully make them understand. Okay, if the language and the numbers are same as you have written, then I have shown. Okay, so Kapil sir, hopefully you can answer this and I need a response. If you need any other clarification, please let me know. I can give this to you. Okay. So can we go beyond this? Kapil sir, is this clear? And Varsha, Meena and others, is this clear? I need a response. Yes sir, वो mental वाला question is clear. ठीक है. So good. Now, so coming back. So Earth's magnetism. Now let us try to understand Earth's geomagnetism. Geomagnetism. So when we say geomagnetism, right, what does it mean? Simply said, Earth also behaves like a magnet. There's the Earth. And let us say this is 90 degree north, Arctic pole. Please do draw with me. 90 degree north, Arctic pole. And this is these 2 points I'm drawing in red color. Let me draw in blue color. या स्नो कवर कर देते हैं इसको. ठीक है, वो ज्यादा अच्छा लगेगा. Okay, so दोनों snow colored thing is the Arctic and 90° south Antarctic pole. Also called as geographical poles of the earth. Geographical poles. We call these two as geographical poles. Why? Because the earth is rotating on the axis passing through this. Okay, we call them as geographical poles because the earth is rotating on the axis passing through this. Right, so this is your earth, 90° north, 90° south. Okay, now the magnetism of the earth means that earth also seems to show a magnetic north and magnetic south pole. Right, magnetism like this. So earth shows a magnetic behavior like this, where it shows this place to have this bluish dot. I'll draw now, to be Earth's, please do draw and write Earth's magnetic north pole. North pole. I'm not writing wrong. North pole. Earth's magnetic north pole. And this upper one near the Arctic region acting as Earth's magnetic south pole. The way magnets have north pole and south pole, these two poles behave as Earth's magnetic north and magnetic south. So Earth's magnetic north is near geographical south pole and Earth's magnetic south is near geographical north pole. The angle between these two is 11 degrees, approximately 11 degrees. The angle between these two is approximately 11 degrees. So the angle between Earth's rotational axis and magnetic poles is 11 degrees. Right? So it is not exactly at the magnetic north, not exactly at the geographical north and geographical south. Slight angle is there. Okay. Do we get it? So this is how Earth behaves, and it creates a, obviously, it will also have a magnetic field. Right. So this way Earth has a magnetic field also of its own. The way magnets have their field, Earth also has a magnetic field. Okay. So this is Earth's magnetic field. Okay, this is what we mean by Earth's magnetism. Alright. So first I want you to draw this much. Here. Alright, this is Earth's magnetism. Once you have drawn this, then you have to write the characteristic of this also. Hence, Earth behaves . like a induced magnet. Earth behaves like a induced magnet. Induced magnet. Within bracket, on which magnet is, which means induced magnet, within bracket, which means magnetism is created. Induced magnet, within bracket, which means magnetism is created. Having its magnetic north pole near, having its magnetic north pole near the Antarctic geographical pole, magnetic north pole near Antarctic geographical pole, and magnetic south pole near Arctic geographical pole. Magnetic south pole near Arctic geographical pole. Full stop. So this is right, and Earth also has its magnetic field due to this. And Earth also has its magnetic field. Earth also has its magnetic field due to this. Earth also has a magnetic field due to this. Okay, right? Next. It should also, next paragraph, very important point. It is also seen that Earth's magnetic poles completely reverse, not partly reverse. They will not keep moving here and there. Completely reverse periodically, after remaining in one direction for few lakh years. After remaining in one direction for few lakh years. Which means, for example, as presently magnetic north pole is near Antarctic. As presently magnetic north pole is near Antarctic. Magnetic north pole is near Antarctic, and magnetic south pole is near Arctic. Magnetic south pole is near Arctic, comma. They will remain like this for few lakh years. They will remain like this for few lakh years. And then completely reverse. Very fast. Completely reverse very fast. And in geography, very fast means a few thousand years. Okay. Completely reverse very fast in a few thousand years. 4, 5,000 years, 10,000 years, something like this. Completely reverse very fast in few thousand years. So they might remain constant for 2, 3, 400,000 years. That is few lakhs. 3, 400,000 years they will remain like that, and then in 3, 4,000 years they will reverse. Okay, reverse very fast in few thousand years. Full stop. This has happened numerous times in the past. this has happened, this reversal, magnetic reversal has happened. This magnetic reversal, right this way, this magnetic reversal has happened numerous times in the past and will continue to happen in future also. This has happened numerous times in the past. This magnetic reversal has happened numerous times in the past and will continue to happen in future also. Continue to happen in future also. Full stop. The real reason for this reversal, the real reason for this reversal is still not known to us. The real reason for reversal is still not known to us. So don't ask me. अभी question मत लिख दीजिएगा सर ऐसा क्यों होता है? Why does the reversal happen? We don't know the reason for this still. Even at the highest scientific level, we don't know the answer to this. Why is the Earth's reversal happening? We still don't know the answer to this. Okay. So the real reason for this is still not known. But we know that the reversal happens. Right? But we know that the reversal happens after few lakh years. And it's a complete reversal. It's a complete reversal. Okay. So after the next reversal, when it happens, after the next reversal, when it happens, Earth's magnetic north pole will go towards. So after the next reversal, when it happens, Earth's magnetic north pole will go towards Arctic pole, and magnetic south pole will come towards Antarctic pole. Magnetic south pole will come towards Antarctic pole. Is this okay? So this is how the Earth's now, why do I tell you this? Because we do see in the recent years there have been some news about Earth's magnetism, right? It comes in the news. Okay, that slight shifting is happening or something. So that's why you should know, because this can come in the exam. Okay. Then next, how is Earth's magnetism created? How is Earth's geomagnetism created? How is Earth's geomagnetism created? Let us write that. How is Earth's geomagnetism created? Earth's geomagnetism created. Write down. 1. The Earth's core is in liquid state. Earth's core has liquid, you write this way, is in a liquid state. You can write this. Earth's core is in a liquid state having iron and nickel. Having iron and nickel. Having iron and nickel. Liquid state having iron and nickel, and hence which are extremely hot, and hence which are extremely hot, having charges, having electric charge, extremely hot, electrically charged, positive, negative, positive and negative, this kind of charge, having electric charge, and because of the movements in the liquid core, because of the movements in the liquid core, these electric charged material, movements in the liquid core, this electric charged material also moves. Electric charge material also moves, creating currents in the core, creating current in the core. Creating current in the core. Right? So you get current in the core. Underline this, current in the core. So you get current in the core, one. Electric current is there. Current is electric current, right? Electric current in the core. Next paragraph. On the other hand, the rotation of the earth creates the physical movement, creates the relative physical movement. You write this way, creates the relative physical movement of the core material. Underline this, relative physical movement. Creates the relative physical movement. Underline relative physical movement of the core material. Full stop. Third line. Hence, Earth's magnetism is created in the third perpendicular direction. Earth's magnetism is created in the third perpendicular direction due to the current and physical, Earth's magnetism is created in the third perpendicular direction due to the current and the relative physical movement. Okay, this way Earth's magnetism is created. So we are applying the same principle that we have seen earlier. Okay, because of that we are getting the Earth's magnetic. This way Earth's magnetism is created. Not only, now next paragraph. So Earth's magnetism created, underline that. Next paragraph, not only Earth, but almost all other planets also create magnetism the same ways. Almost all other planets also create magnetism the same way in the solar system. Magnetism in the solar system, except for Venus, which does not have magnetism. Venus, which does not have magnetism, because it rotates very slow. Nearly 250 days for one rotation. Even for one rotation, it takes around 250 days. Rotates very slow. Nearly 250 days for one rotation. So because that physical movement doesn't happen, so it doesn't create enough magnetic field. Right? And second, Mars also does not have any considerable magnetic field. Because its core is relatively much cooled down. Core is relatively much cooled down. So it doesn't have that hot charged particle state. Much cooled down. Alright, so this is your Earth's magnetism and the magnetism of many other planets. Many other planets also, except for these two. Now, the importance of Earth's magnetism. Importance. What is the importance of Earth's magnetism? Earth's magnetic field is able to deflect. The Earth's magnetic field is able to deflect away the solar charged particles coming towards the Earth. Earth's magnetic field is able to deflect away the solar charged particles deflect away the solar charged particles coming from the sun towards the Earth. Suppose these are the solar charged particles, they are coming toward the Earth. So it is able to deflect away the solar charged particles coming from the sun. Earth's magnetic field is able to deflect away the solar charged particles coming from the sun, which could otherwise harm the living beings on the Earth. If you have very high solar charged particles, which could harm the living beings on the Earth, which could otherwise harm the living beings on the Earth. Right? Now, what are solar charged particles? Solar charged particles are charges, some charged particles which the sun tends to send, like this. This is sun. This is how the solar charged particles are created, and they tend to come toward the Earth. Now you can see the Earth's magnetic field has protected the Earth from the solar charged particle by deflecting it. Right? So the solar charged particles are not allowed to enter into the Earth's magnetic field. Okay? So this is how the Earth's magnetic field protects us from the solar charged particle. They are very high energy currents coming from the sun. So they can harm us if they reach the Earth. Do we get it? One. Second, Earth's magnetism is also used for navigation. Earth's magnetism is also used for navigation. Both by human beings and by migratory birds and animals. Migratory birds and animals, as they have biomagnetism. The migratory birds and animals have biomagnetism, something called as biomagnetism. Right? So they are able to sense and move accordingly, as the migratory birds and animals have biomagnetism. Human beings use compass. Human beings use magnetic compass, right, in navigation. In the ships and all, you must have heard in ancient days, they used to use magnetic compass for navigation. Okay, so these are the two major uses of Earth's magnetism, right, that we have. These are the uses of Earth's magnetism. It protects us from the solar charged particle and this. Now, Shubhode, what will be the impacts due to reversal of magnetic pole of the Earth? The impact due to magnetic reversal of the Earth, or how we use it, and all we will do in the next topic, not here. Okay. So magnetic reversal does not broadly adversely affect us in many ways, right? We don't know exactly, and it's not within our syllabus. Also, I should say, what are the impacts of magnetic reversal is not within our syllabus. But how do we use Earth's magnetic reversal? One part of it is there in continental drift theory. That we will do there. But otherwise, we don't have to touch this topic. Okay. So this is Earth's magnetism. Is this clear? Right? So Earth's magnetism, related aspects, and all this. Hopefully, this is clear. If you have any doubts, you can send it to the coordinators. They can help. Right? And just revise this part once, especially the part which sounds slightly science like to you. उसको एक बार revise कर लो. I have tried to make it as simple as possible and given it to you. Right? So this is what we needed to know. Now, once we are done with this, the next thing that we need to take up is, so Earth's magnetism is also complete. Okay, this topic completed. Right? Paleomagnetism and all we'll talk of later. Continental drift, seafloor spreading theory also. In seafloor spreading theory also we have used Earth's magnetism. Right? So there we'll talk of it. Now let's come back to the next topic. So Earth's, we understand the interior of the Earth and the magnetism of the Earth. The next topic that we have to talk of is the movements of the surface of the Earth. Write this. Next topic is movements of the surface of the Earth. Of the surface of the Earth. Movements of the surface of the Earth. Okay. Now, first of all, what do we need to understand? What are the surface of the Earth? What do we have on the surface of the Earth? When we say the surface of the Earth, what do we have on the surface of the Earth? On the surface of the Earth, we have continents and ocean floor, right? When we say the surface of the Earth, we mean continents and ocean floor. So basically, we have to talk of movements of the continent and ocean floor. Okay. The next topic we have to understand is movements of the continents and the ocean floor. How they are moving and are they moving? Now, this might be new to you, right? I believe this must be a new topic to many of you, and many of you might be shocked right now if you have not read your NCERTs. That, sir, what are you saying? Are the continents and the ocean floor moving? The answer is yes. Okay. So now this is something that we have to do, right? Now, before I tell you this, I will tell you the background, slight background we'll try to understand, right? Now, for example, right, in the ancient past, we used to think that the earth is fixed and the stars and the sun and the moon are moving around the earth. Okay. So this was our understanding of the earth. Earth is fixed and everything is moving around the earth. Okay. So the star moves around the earth and the sun also moves around the earth, right? And later on, Copernicus found out that it is not right. Actually, the earth itself is moving. The star and the sun is not moving around the earth. The earth itself is rotating. So Copernicus was the one who told us that the earth is moving. Before that, people were not ready to accept that the earth is moving. They were used to think that everything is moving around the earth. Earth is fixed. Okay, Copernicus told us that the earth itself is rotating. Same ways, we or many, you can say still most of the people around, or for almost all that period up to 1900 something, most of the people, almost everyone used to think that the surface of the earth, such as continents and seafloor, are fixed. They are not moving, right? But some scholars started presenting different views in the past gradually. How? So scholars like, you can write 1596, in the year 1596, Abraham Ortelius, please do write. Abraham Ortelius, and later on Antonio Pellegrini. Later on, Antonio Pellegrini stated, right, Abraham Ortelius and Antonio. So I want you to write down this, right, that earlier we used to think that the surface of the earth, earlier we used to think that the surface of the earth, within bracket, the continent and the seafloor, surface of the earth, within bracket, continent and seafloor, were fixed. But scholars like Abraham Ortelius and Antonio Pellegrini, stated that it seems that if we cut the continents, shape at their margin, it seems that if we cut the continent shapes at their margin and put them together, cut the continent shape at their margin and place the continents together, then they might fit as pieces of a bigger block. They might fit as the pieces of a bigger block. Pieces of a bigger block, like this, you can see here. Fit like the pieces of a bigger block, which indirectly implies that the continents might have been together in the past, which indirectly implied that the continents might have been together in the past. As a one big block. And they have moved to their present positions later. But these scholars did not emphasize this movement part much. These scholars did not emphasize this movement part much. Explicitly. Full stop. It was only in the year 1912. That another scholar by the name of Alfred Wegener explicitly talked about the movement of the continent and gave the continental drift theory gave the continental drift theory, which was partly right. Partly right. He was not fully right, which was partly right. About the movements, which were partly right about the movements of the continents and their cause of movement. Partly right about the movements and the cause of movement. Next, then in 1930s, Arthur Holmes gave the convection current theory. Convection current theory of the mantle. Convection current theory of the mantle. Okay, Arthur Holmes gave the convection current theory of the mantle, which was the cause of movement of the continents. Which was the cause of movement of the continents. Cause of movement of the continents. Then in 1961, Harry Hess 1961, Harry Hess gave the seafloor spreading theory. Gave the seafloor spreading theory about the movement of the seafloor. About the movement of the seafloor. About the movement of the seafloor. And in 1967, an all-inclusive plate tectonic theory was given. All-inclusive plate tectonic theory was given. Now, plate tectonic theory was all-inclusive. It included all the movements, all the causes, everything. All-inclusive plate tectonic theory was given, right? Which we will discuss, right? Which we have to discuss. Okay, so we will discuss this order. In this order, we will discuss the things. Okay, so first we will discuss Wegener's theory, then Arthur Holmes, then Harry Hess, and then plate tectonic. What should be the source? The source is chapter number 4 of NCERT. Chapter number 4 of NCERT gives you all this. So please read chapter number 4 of NCERT. Okay. And to support, you can read the Vision IS material on plate tectonics. Vision IS material on plate tectonics. Don't read any other source right now. Not needed. Okay. So this is what I expect you to read. This is where we stop the class for today. Next class we start from here. Okay. So hopefully this much we understand today. What we have to read in the next class, I have told you. Read chapter number 4 of NCERT, Fundamental of Physical Geography, and Vision IS material on plate tectonic gradually. Not tomorrow's class, next class. First read continental drift, then the Arthur Holmes convection current theory, and Harry Hess seafloor spreading theory from NCERT. Only from NCERT. No need to go anywhere else. For plate tectonic, you can read the Vision IS material. Okay. So this is where we stop today, right? The class is over. Classroom coordinators, I don't see any other major doubt. Please confirm. If you want me to take up any other doubt, please write. Otherwise, that's it. Thank you. Students, also, I believe this much is clear to all of you. So that's it. This is where we end the class today. Thank you. All right. So that's it. Okay. टेक्निकल टीम क्लास ओवर है, अभी मैं माइक ऑफ कर रहा हूँ, 2 मिनट में ऑफ कर देता हूँ। आई एम जस्ट वेटिंग, एक बार ये लोग कंफर्म कर दें। Is there any other major doubt you want me to take up? Classroom coordinators or something? No, none. टेक्निकल टीम 1 मिनट रुक जाइए, मुझे थोड़ा सा रिस्पॉन्स देख लेने दीजिए। क्लासरूम कोऑर्डिनेटर, इज देयर एनीथिंग एल्स? कपिल सर, यू वांट मी टू टेक अप? Is it right that Borewell also goes to the Earth's asthenosphere? The Borewell can go to the asthenosphere if your Borewell is 30 kilometer deep, which we don't do. So I hope you understand. It doesn't. The answer is no, it doesn't. Compass showing north and south direction wrongly by 11 degree. You can say to some extent, yes. Please repeat, sir. I can't. I don't know what you are asking me to repeat. How magnetism created? I have explained. Sir, did Earth had magnetic field when Earth's first atmosphere was blown away by solar wind? Not much strong. And they were not blown away only by solar wind. They were also lost because they were light gases, very light gases. आकाश ठीक है, धीरे धीरे समझ में आ जाएगा। Sir, why don't we feel the imbalance? Sir, what was concept? It is like the aeroplane flying in the atmosphere at a speed of around those 500-600 kilometer per speed per kilometer, 600 kilometer per hour, but you still don't feel imbalance standing in the aeroplane, ना? ठीक है? What was concept of people about earthquake if they think Earth's surface is fixed? I don't know. What was the year, sir? I gave all the years. 1596, yes. Sir, please can you use some printed pictures like solar charged particles picture for better and quick understanding? Flix was also there with Harry. Okay, ठीक है. Whoever. Sir, when the Earth is moving at very high speed, I have answered. Sir, Earth's magnetism, what should we read? You don't need to read anything. We have done enough for Earth's magnetism. That's it. Thank you. Thank you. Have a great day. Thank you, everyone. Right? And coordinators, no major doubt. Thank you, Kapil Chaudhary, sir. That's it. Thank you.